I want to talk about limits, in particular the limit of science and our understanding. Limits are great sometimes. In fact, they avoid problems and give us knowledge, and I'm motivated to do so because the 21st century passes so fast that we have not stopped to review the limits. What I like to do today is show science in perspective. If you allow me, I will show you a comprehensive vision that involves both what we know and what we do not know. In the end, I will share my concern about it, and from there, you will be free to make your own conclusions. Okay? You already know that biology means the study of life. That does not necessarily mean that we have understood it. Limits are fundamental in science and technology. In the last 60 years, we have multiplied by 4 the top speed of motor vehicles. What if I tell you that it was thanks to the brakes that we have come so far? Do you have any doubts about it? Do you think it was thanks to the engines? Well, if your answer is engine, then put one of these together to see if your wife wants to go for a ride. People who understand motorsport world, professional or weekend hobby, knows it. To go faster, it is not enough to think about more powerful engines. You must first think of more sophisticated brakes. You should even consider other issues that were not so important before. The clutch, the steering, shock absorber, etc. I'm going to put the turbo on my car. And have you thought about how you are going to stop that thing? Knowing the limits in the last 60 years expanded our limit, and very important, in safety conditions. What happens if we ignore or do not know this dynamic? The worst part happens. As a simple fix becomes a national tragedy. Hurry up. Make the quick fix because I have to win the race. Or the most recent one from last year. Hurry up, scientist. I want to get the injection before my competition. Well, enough of dramatic stuff. Let's switch to something more enjoyable. Everything is going very fast with technological advances. Computers, telephones, the internet. We almost build our reality around these wonders. I want to show you an important process for everyone. This is our technological process, the ingredient of technology. Here is the kitchen of modernity. We mix these ingredients and make all kinds of gadgets, the world we created after the 1940s. The central heart of our technology is called transistor. There you have it. From the beginning, we knew that silicon had natural limits due to some quantum issues. Going down from 14 or maybe 10 nanometer would be very complicated and expensive. We didn't know exactly how much, but we knew it would limit the electronic evolution. A very brief explain about what a transistor is. It is an extremely pure piece of silicon made from molten beach sand. I open some particular contacts called drain and source that have previously increased their charge on each side. Then I open another contact that I have previously separated with a silicon oxide insulator. That is the same sand but oxidized, and we call that gate. And adjusting that gate voltage results in controlling the amount of electrons that pass from drain to source. Do you want me to explain it easier? It's a faucet, like a sink faucet in your kitchen. But instead of controlling water, you control electrons. Everything around you is now full of transistors. The camera through which I am recording this video, the phone that you are watching me, the computer, the LED lights in your house, the appliances, your car, everything. And I mean everything. Why we did relatively well with that? Again, why do you think? We always had full knowledge of the limits. That led us to study deep down the nature of materials. We understood how single transistor worked, as well as how it works when grouped with others. And something very, very important, we truly understood the communication of the parts. In creating that world, we focus on having the integral vision. With that said, now I'm going to introduce you another process, one more important than previous one. Ladies and gentlemen, give a warm welcome to the wonderful phenomenon of life, a phenomenon that biology has dedicated itself to studying. Over 99% of everything you see in the two pictures below is made up of the same 11 ingredients, including you, yes. And if we include the elements of group 3, in total there will be a few dozen of elements. Yet, this process results in an astonished variety of form in both the animal and plant kingdoms. Now I'm going to confess to you the best kept secret of biology and one of its children, medicine. But I ask you a favor, I beg you, do not tell any doctor or biologist who is too attached to his profession, because I don't want problems, okay? I'm going to tell you. Here we go. Do we know how this process is carried out? No, we don't. How are the ingredients mixed and organized to build life forms? We don't know either. Yes, we know that sperm and ovum unite in mammals. They start to exchange information. We know that the zygote forms later and the embryo start growing. That's all, folks. We don't know much else. We know the consequences, but the whole process in origin, we don't know. And in the next stage, how could it be possible that similar embryos from one moment to another explode in thousands of differences? We don't know. But don't ever tell a gynecologist that we don't have any idea of these specific things from living beings. I advise you, do not touch the morphogenesis issue. Warn you, it will be a very bad conversation, okay? For now, we have two unknowns on the list: the self-organization of living system and the morphogenesis of cells from non-living components. These 2 points are natural limits to our knowledge. Pay attention to them. In fact, Professor Erez Brown from the Technion University of Israel has been saying for a long time that we urgently need a theoretical model to understand the physics of living systems. Until now, we don't have it. Now we are going to put together the two most important processes of the 21st centuries. Here they are side by side. Look how wonderful. On the left side, there are some ingredients, and we put our hands there to make that happen. We are the creators. On the right side, we, for now, do not understand many things. Much of the process we do not have the remotest idea. Behind the scenes, we don't know how the things work, ladies and gentlemen. And look how curious. There are even common elements, but in one, there is a life, there is a self-organization, and in the other, there is not. And what happens if we continue to break down these two hyper-mega important processes? We will continue to find many similarities and systemic group levels. Okay, I admit it. Engineers and physicists always copy things from nature, or at least we try. But how strange. In technology, the programming code appears after creating the transistor. The chip, at least today, is dead until I connect it with other part, insert the program, and I have done that, and then it acquires its functionality. In nature, however, we also find something called code, program, but look how interesting. It is present in all organization levels. The cell in biology already seems to have a program. It has a functionality, unlike the transistor in electronics, which at the time of creation we have no idea of the functionality it will contribute. What are those codes? On the left, it is the code we use in technology. On the right, we have a little snippet of DNA code that I took from Chapter 1 of the human genome. It is public info on the internet. And now the expert will tell me, hey Giuseppe, the points we don't know are finally over because we discovered the DNA since 1953 and we have the entire genome, so game over. Well, I have difficult news for you. It is true that we know the code. It is true that we know the apparent individual functionality of some part, but genes communicate and exchange information between them. A topic that was discussed even before the discovery of DNA. Barbara McClintock, between 1930 and 1940, realizes that in plants, pieces of chromosome without much explanation moved to other chromosome. But science did not believe her. And Berlin procedure of our science, where I saw that before. They discredited her work in 1957 and told her not to publish any more of that madness. The bullying of scientific society lasted until 1980, when it became very evident that there were movable elements of the genome not only in plants, but also in animals. Happy ending for her. She won the Medicine Nobel Prize in 1983. But it was difficult for DNA decoding works because between 1950 and 1980, the DNA was considered static, not dynamic. So, unknown number 3. We don't know exactly what cross-communication between genes is like. As in morphogenesis, we don't have an established theoretical model either. In short, there is the file with the data, but almost no idea about how it is executed and also how the program communicates. That brings me back to this slide where I confess there is an error that we have carried since the 20th century. Today, we know that nature analyzes the current step to execute the next step. That is, it uses a way that in statistics we call stochasticity. Therefore, last stories indicate that this code is not complete from moment zero. It is formed as the creature evolves in its formation. As demonstrated by Professor Dennis Noble, life is a process, like music, but it is not completely programmed at the molecular level. And this is perhaps the greatest learning of the 21st century in terms of living systems. Why didn't we see it since the second half of the 20th century? I will give you a short possible answer. Because for decades we were possessed by a mantra, oversimplifying the logic of living systems. We thought in a linear way from molecules to humans as if it were a one-way process. It cannot be true because molecules are simply not living beings. Who was responsible? 3 guys: René Descartes, Erwin Schrödinger, and Pierre Laplace. Especially Schrödinger, the most recent of the 3. He said 2 things that were assumed as dogma by 20th century science. 1. Physics must generate order from disorder. He reached this conclusion by observing the gas dynamics, disorder in free movements, very ordered when circulation in a space was restricted. And 2. Biology, in contrast, must be the generation of order from the molecular order. The first sentence, okay. The second, about biology, we know today that it is not true. It is impossible for a molecule in biological system to be immune to the random energy that connect it to other molecules. And I do not want to go deep into this. If you like, you can look for the latest work of Professor Dennis Noble and you will surely surprised. But we know that today. We didn't know yesterday. So, like physics, biology is also about order from disorder. And as you already know, we don't have much idea how that works. So, yes, this is the 4th and final unknown, the mechanism that living systems use to obtain order from disorder. These 4 mysteries, the 4 unknowns, represent complicated limits to our knowledge. And the biggest problem for biology and its daughter medicine isn't that we don't know how to solve it. The biggest problem is that we are ignoring them to establish the next scientific truths. I would like to give you another short information as a result of the unknown number 4 and of course the work of Professor Dennis Noble. Gene expression turned out to be a stochastic process too. A classic example is our immune system. It fixes a good part of the immunoglobulin code so that there is no modification of the protein, so it will always be immunoglobulin, but then it randomly moves a part of that code in order to find a solution to a problem. bacteria, virus, or any invader. In this way, it finds the code to solve the problem, gradually analyzing the next state, leaving most of the part fixed, static. Okay, much easier. The immune system is like a slot machine that holds some wheels and only let a few to spin, a way to increase the probability of success. And nature always wins. What a brilliant trick of nature. Discovering all these things toward the end of the 20th century and start to understand them at the beginning of the 21st century made it clear that we did not understand anything about living beings during the 20th century. And we still have many unknowns, but it opened new horizon for us. The cells of living systems are not handled randomly, as was believed. They actually take advantage of randomness to improve, something that our science and our technology do not work like that. I don't have much time, but let me conclude. From now on, I'm concerned about two things. Do you remember when I explained the transistor, silicon, beige sand, the limit of silicon? Let me give you an update. At the beginning of the 21st century, we were integrating DNA with silicon. Once again, an innovation made by Israel. Now we have made other progress. The manufactured transistor, we can not only use carbon, nanotube, and DNA, of course, but also we can imply the most recent discovery, graphene and its insulator, graphene oxide. And why am I worried about that? Because by using these materials, we are reaching the electrical operating threshold of our cells, which means that we are opening the door for this technology to be compatible with our bodies. How good? We can solve people problems. Yes, except for one little issue. The unknown number 4. We will take elements that we have artificially created with the science based on order from order, silicon, graphene, etc., and we will introduce them into living systems that were created by another science that seeks order from disorder. We have no idea what that might result, and we don't know the impact it will have on the cell program, the code, remember, the DNA, and that is up the unknown number 3. This brings me to the second concern. At the same time of these technological advances, we have started to play with injection containing messenger RNA. In other words, a piece of code that wants to interact with our code. Definitely such innovative products. Indeed, we have made great progress in gene editing. Recently, a novel editing technique called CRISPR-Cas9 was invented at the Berkeley University. The co-author won the Chemistry Nobel Prize in 2020. And I also know that we have advanced a lot in recognizing the function of many genes, in understanding many aspects of our immune system. However, the 4 unknowns are still above us. And my concern is that with all these genomic technology initiatives, we are ignoring the unknowns, plus we still do not have an integral vision. The worst part that could happen is turning our eyes blind to these limits, because our science has shown since time that when we ignore them, or even when we don't properly estimate them, things always get out of our hands. Eventually, I don't see that nature is disordered. I see our lack of humility. We should recognize that we have not understood its order, that apply to all branches of biology, including medicine. And now that I have shared this material with you, it's up to you. You decide now what you will do with this information. From my side, I just hope you will make the best decision. Thank you very much.